to talk about environmental engineering. The purpose of my talk is to introduce to you what the general concepts about environmental engineering is and how we do perform an environmental analysis report. I want to start saying that our common future, also known as the Brundtland Report, was the first time that the scientific community tried to address the environmental problems. Our common future was delivered by United Nations World Commission on Environment and Development in 1987. This document was a culmination of our 900-day international exercise, which cataloged, analyzed, and synthesized written submissions from expert testimony from senior government representatives, scientists, and experts, research institutes, industrialists, representatives of non-governmental organizations, and the general public, held at public hearings throughout the world. And it was the first attempt to try to solve one of the most important environmental problems at that time. After the Second World War, after many decades of industrial revolution, society wanted that science meet the economy. We wanted to address for the first time the environmental issues, and we wanted to link together economy, science, and development. One of the most important mandates of the Brundtland Commission was to re-examine the critical issues of environment and development and to formulate innovative, concrete, and realistic action proposals to deal with them. The Brundtland Commission also wanted to strengthen international cooperation on environment and development and to assess and propose new forms of cooperation that could break out of existing patterns and influence policies and events in the direction of needed change. Finally, the third mandate of the Brundtland Commission was to raise the level of understanding and commitment to action on the part of individuals, voluntary organizations, businesses, institutes, and governments. The Commission focused its attention in the areas of population, food security, the loss of species and genetic resources, energy, industry, and human settlements, realizing that all these are connected and cannot be treated in isolation one from another. The report offered the analysis, the broad remedies, and the recommendations for a sustainable course of development within such societies. However, Brundtland's report was unable to identify the models of production that are responsible for degradation of the environment. And in the absence of analyzing the principles governing market-led economic growth, the report postulated that such growth could be reformed and expanded. This lack of analysis resulted in an obfuscated introduction of the term sustainable development. The sustainable development term is in the core of every posterior environmental analysis. I think that the introduction of the sustainable development concept was the main objective, the main goal of Brundtland Commission. The publication of Our Common Future and the work of the World Commission on Environment and Development laid the groundwork for the governing of the 1992 Earth Summit and the adoption of Agenda 21, the Rio Declaration, and to the establishment of the Commission on Sustainable Development. As I said before, the sustainable development concept is at the core of every environmental analysis performed by engineers, environmentalists, biologists, and chemists all over the world since 1987. And it has been introduced on every environmental legislation. Nowadays, it would be impossible to understand environment without taking into account the sustainable development concept. We can define sustainable development as the development that meets the needs of present without compromising the ability of future generations to meet their own needs. In 1972, it was published The Limits to Growth, which is a book about computer modeling of exponential economic and population growth with finite resource supplies. It was funded by the Volkswagen Foundation, and it was commissioned by the Club of Rome. It was first presented at St. Gallen Symposium. Its authors were Donella Meadows, Dennis Meadows, Jorgen Randers, and William Behrens III. The book used the World 3 model to simulate the consequence of interactions between the Earth's and human systems. It was the first attempt to model the relations between economy and environment. We can see that these relations have been treated only very few decades ago. From 1972 to today, substantial improvements have been made. One key idea of the limits to growth is the notion that if the rate of a natural resource use is increasing, the amount of reserves cannot be calculated by simply taking the current known reserves and dividing by the current yearly usage, as is typically done to obtain a static index. For example, in 1972, the amount of chromium reserves was 775 million metric tons, of which 1.85 million metric tons were mined annually. The static index is therefore 775 divided by 1.85, so that is 418 years. But the rate of chromium consumption was growing at 2.6% annually. If instead of assuming a constant rate of usage, the assumption of a constant rate of growth of 2.6% annually is made, the reserves can be calculated as the formula shows. We get then that the amount of chromium reserves will last only for the next 95 years. In general, we find that formula for calculating the amount of time left for a resource with constant consumption, which depends on the total years left. The factor R equal to 0.026, the continuous compounding growth rate is 2.6%, S, which equals R divided by the annual consumption, which is called the static reserve, being capital R, the reserve. The environmental system is complex, and it includes the natural ecosystem and all the human activities which are done inside them. The environmental management analysis tries to understand all the disequilibriums that human activities induce on the natural ecosystem. This environment understands every possible units. We can divide environment, therefore, in many different units which we will be able to understand following different information sources. All this information comes from different scientific areas, like cartography, aerial photography, remote sensing, statistical data, human resources, chemical analysis, and many others. We are currently finding two kinds of environmental problems, depending on their scale of analysis. If we analyze transnational and global problems, we will be dealing with problems that affect nations or even continents, all at the same time. Every day we are dealing with many of other problems, which are also located at a local, at regional scale. The most important transnational and global problems are resources depletion, oceans contamination, deforestation, global heating, ozone layer deterioration, atmospheric acidification, biodiversity loss, natural disasters, and in general, many other systems disequilibrium. On our everyday life, we are dealing with local and regional problems which affect our natural environment and that are caused by industrial activities, agricultural activities, and municipal activities. The environmental management procedure is a set of procedures through which a public entity may intervene to modify and organize activities that affect the environment as well as to reduce their impacts. The environmental value of a certain area can be defined as the degree of usefulness or fitness for a geographic area defined by the competent authority in accordance with the natural features of the landscape, in compliance with environmental quality standards, with the presence of species or protected areas, and its landscape values. These aspects are set in relation to its uniqueness, scarcity, representativeness, endemisms, biodiversity, and conservation status. Many different international research projects, for example, like those one funded by the European Union, are oriented trying to understand the environment on this more general way. After the years, on the European Union legislation, a general procedure to understand the environmental assessment process has been set. All this process starts with an idea, which is being defined technically on a document which is called technical project. These technical projects are written by engineers and technical people, and these projects describe graphically and technically every single aspect of this idea. For example, let us try to understand how we build a dam. It all begins with the idea, searching the best place, and afterwards, a technical project has to be written. In this technical project, every feasible technical alternative has to be included, including, of course, the justification of the location of the dam. This technical project has to be analyzed, trying to understand and identify all the actions that the project induces on the environment. Afterwards, we have to describe the environment. We are going to write what it is called an environmental analysis. And we are going to use mathematical models in order to quantify which are the environmental impacts that the project induces over the environment. Finally, looking to those environmental impacts, we will describe and define the correction and mitigation measures. We will quantify their value, and we will change the technical project accordingly. So the technical project will be modified after the environmental assessment process. In order to perform a full description of the technical project, both the construction phase and the operational phase has to be analyzed. For some certain type of projects, the abandon phase has also to be analyzed finally. But for every technical project, at least the construction and the operational phase must be analyzed. This analysis has as a goal to identify the full list of actions, as I say, both on the construction phase and on the operational phase. And this analysis must be performed for every feasible alternative. Typically, on a civil work technical project, dozens or even hundreds of actions must be identified. On the example we were talking before about building a dam, some examples of actions during construction phase could be temporal closing of the river, destruction of vegetation, or traffic on heavy machinery during the construction phase. During the operational phase, some example of actions could be creation of new ecosystems, changes in local or even regional economy, or changes in the hydrology behavior patterns. As we see, the consequences of these actions depend mostly on the environmental system in which we are building our project. This environmental system is going to be described following an environmental inventory procedure. For a specific location, we will define and describe both the abiotic and the biotic factors, being all of them called environmental factors. So the environmental inventory will include all the possible environmental factors that we find on every single location. Some of the most important abiotic environmental factors are the analysis of water, atmosphere, soil, landscape, economy, and cultural heritage characteristics of a certain area. Biotic factors are mostly focused on the analysis of flora and fauna, and especially induced to analyze the local endemisms. By writing this environmental inventory, we will have a detailed description of every environmental factor that could be affected by the project. Therefore, on the environmental analysis of a certain location, we will have many different environmental factors. Sometimes we will have 20 or more. So, in order to get all these informations, nowadays, fortunately, we have a very large amount of information sources, like internet, in which we are going to be able to obtain online information at real time from most of these environmental factors. The environmental impact assessment process starts then with the analysis of actions on the construction, operation, and closing phase. And we are going to relate these actions with each one of the environmental factors. We are going to build one matrix which analyzes the possible relations between all the actions on the construction, operation, and closing phase of the project with every one of the environmental factors. And we will ask ourselves if there is any relation between these actions and each one of these environmental factors. Probably there will be no relation between them. But sometimes we will find that there is a very close relation between some actions and some factors. For example, building a dam will dramatically change the hydraulic behavior of a certain area. Then we will have to identify what we call an environmental impact. The impacts matrix is formed by the identifications of all these relations between actions and factors. Then, afterwards, we will have to analyze one by one each one of these environmental impacts. And therefore, we will know what the effects of our project has on the environment. And we will be able to define the better correction and mitigation measures in order to maximize the effect of the positive impacts and minimize the effects of the negative impacts. By doing that, we will probably have to change the technical project, and we will probably have to modify their budget also. This is the general environmental impact assessment process that has been implemented on the European Union legislation. In order to quantify evaluate the magnitude of the impacts, we have two different possibilities. We could use a qualitative evaluation or a quantitative evaluation. In order to avoid subjectivity, we will have to perform a very strict analysis of the magnitude of these impacts. We will have to study the interactions between the different actions caused by the project and the specific features by the environment, categorizing the environmental impacts as compatible, moderate, severe, or critic. But as I said, if we try to avoid subjectivity, nowadays we are going to use mathematical models. Mathematical models is the tool that science gives us in order to try to perform strict analysis that could be shared by the scientific community. The use of mathematical models is nowadays more and more used on the environmental analysis reports. We have introduced the Brundtland report, and we have introduced the environmental impact assessment process. These are two keys of every environmental analysis, and they are broadly used on environmental engineering at a first step.